The Leave Plan of Room specialists has found that using our new $101 billion tool, it will apparently be perpetually before that try changes into a reality. On the remote possibility that it goes as planned, the excursion to Proxima B will take nearly 20 years. So, sensibly, it will be a few years earlier before we can inquire if there is certain life on that planet. The age-old question of whether we are really alone in this universe persists. The James Webb Telescope has discovered some astoundingly human-like elements far away from Earth, leading us closer to an answer. Our mission for life beyond us has been relentless throughout every human epoch, so much so that we have countless media works and theories on this matter. Our wonder concerning our place and loneliness in the universe has been consistent. It is embedded within us to continually seek companionship, no matter how remote or incomplete it might be. We may draw closer to the answers we seek, but are they truly the answers we want? Or are they perhaps more unsettling? Join us as we explore the latest discovery in the realm of systems and planets on the journey to finding something we may not be prepared to see. Far-off lights have been detected, and researchers believe they might be the most profound discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, an intriguing hypothetical question was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet, for example Proxima B. Proxima B, the closest exoplanet to Earth, is about 4.25 light-years away. It was determined to be tidally locked, with a permanent day side and night side, much like our Moon. A theoretical, imaginative enhancement for Proxima B could involve transferring power and energy from the day side to the night side using photovoltaic cells that generate power from starlight. In a paper with Manasvi Lingam as one of the scientists, it was suggested that a massive concentration of solar panels on the day side could be detectable by future telescopes. Since the James Webb Space Telescope, JWST, was also developed, it allowed us to expand our search for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did precisely that in 2024, using its higher sensitivity and greater capabilities, is pivotal. The JWST may have found the lights we were searching for and perhaps propelled us into another massive surge of human activity overall. Let's delve into the universe of planets and exoplanets to understand how this was even possible. James Webb's mission, Proxima B and its secrets. From the dawn of written history, humans have pondered the possibility of the universe. What we are, where we come from, and where we go. These are timeless yet profoundly difficult questions that humanity has tried to answer since gaining self-awareness. In this age of incredible technological advancement, one might wonder if we are any closer to finding these answers. If you were to ask a philosopher, they might say we are still at level 0 in understanding ourselves and the universe. However, if you asked a space scientist the same question, they would likely burst with excitement as they shared the latest discoveries about the universe using their advanced tools. These tools, often not well known by the general public, are now a reflection of human ingenuity itself. We currently have the world at our fingertips, and it's time to take the universe within our grasp. One way scientists and astronomers aim to achieve this is through technology. One such creation, now responsible for the groundbreaking discovery of what might be light on another planet light-years away, is the James Webb Space Telescope. The James Webb Space Telescope is the result of a legacy of human exploration into space, created to address age-old questions. Are we alone? Who's out there? Where do we start and where do we end? This infrared astronomy device has already begun seeking answers to these questions. If you are unfamiliar with Proxima B, here's some context. Proxima Centauri B, or simply Proxima B, is sometimes referred to as Alpha Centauri B. It is a super-Earth exoplanet that orbits an M-type star. Super-Earths might confuse you, but don't worry. This explanation will clarify. Super-Earths are a category of planets that are more massive than Earth but lighter than ice giants like Neptune and Uranus. They are truly unique and can be composed of gas, rock, or a mix of both. Their sizes can range from twice the size of Earth to several times its mass. In the case of Proxima B, it is a super-Earth and an exoplanet, meaning it orbits outside our solar system. The first possible evidence of an exoplanet was discovered in 1917, though it generated little interest. However, confirmation came in 1992 with the first verified discovery, which left scientists astonished. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These remarkable discoveries surround M-type stars. To understand M-type stars, you need to grasp the concept of red dwarfs. A red dwarf is the smallest type of star in the main sequence, hence its name. In the vicinity of the Sun, red dwarfs are by far the most common type of star found in the Milky Way. They have incredibly low luminosity, and since brightness is one of our primary tools for planet detection, red dwarfs are not easy to spot. These dim stars have variable definitions and names depending on their temperatures and sizes. For example, M-dwarfs or M-type main sequence stars have a maximum temperature of around 3000 K, which gives them their name. In the case of Proxima B, its mass is comparable to 1.07 Earths. Interestingly, it takes only 11.2 days to complete one orbit of its star, compared to our 365.25 days. This speaks volumes about the size of the star Proxima B orbits. When analyzed across the electromagnetic spectrum, the star has a total luminosity of only about 1.6% that of the Sun. Additionally, in the visible light spectrum, its brightness appears even dimmer, at just 5 to 6% of the Sun's brightness. It emits an even smaller amount of light energy compared to the Sun. Over 85% of its emitted energy is in the form of infrared radiation. Orbiting at about 0.045 to 0.056 astronomical units from its star, Proxima B was discovered in 2016. You might ask, with a million stars, planets, and galaxies, why is Proxima B of such focus? Well, there are several reasons that make it significant. Premium cosmologists have observed that Proxima B is the nearest known star to our Sun. By definition, albeit 4.2 light-years is a significant distance to us Earthlings, in the grand plan of the universe, it is a straightforward blip. Consequently, Proxima B, our closest known star, is high on the priority list. It is part of a triple star system called Alpha Centauri. Despite Proxima's glow being incredibly low, the system appears as one of the brightest celestial bodies in the night sky, behind two others called Sirius and Canopus. However, the most enchanting thing about Proxima Centauri B is that it could truly be habitable, as it falls within the habitable zone. The possibilities surrounding this star are endless, and cosmologists have taken on the task of exploring the depths and limits of its true potential. That is where the James Webb Space Telescope, JWST, comes in. The four primary objectives of the JWST are to 1. Search for light from the first stars and galaxies that formed in the universe after the Big Bang. 2. Study the universe's evolution and development. 3. Investigate star and planet formation. And 4. Focus on planetary systems and the origins of life. As the JWST continues its assessment of exoplanets like Proxima B, we draw closer to achieving these goals. From searching for exoplanets to seeking extraterrestrial life, we are venturing into uncharted territories. So what exactly is SETI, one might ask? Considering humanity's inherent curiosity, examining and exploring everything around us, it makes sense that a mission like SETI, Search for Extraterrestrial Intelligence, would emerge on such a grand scale. Imagine a massive endeavor orchestrated with a touch of divine inspiration. Humanity is tasked with seeking out signals, more specifically electromagnetic murmurs, from civilizations far beyond what we could ever imagine. SETI resembles the world's highest-stakes game of hide-and-seek, with us as the seekers and the vast universe as the seemingly endless hiding spot. Experts in this field are like advanced detectives, tuned into radio waves and scouring for a subtle, "we are not alone" signal. This cosmic investigation began in the 1960s when Frank Drake, a remarkable astrophysicist, was among the first to detect radio transmissions from the stars. It was a monumental moment, though no aliens appeared on his doorstep, at least not yet. As you might have guessed, searching for something this monumental requires patience and spans many years of work. Few definitive alien transmissions have been found, but the excitement continues to grow. As the James Webb Space Telescope examines exoplanets like Proxima B, a field of hope is emerging. Will we stumble upon concrete evidence of extraterrestrial life, or will we encounter enigmatic transmissions just outside our comprehension, raising more questions than answers? The discovery of lights or artificial signals from distant exoplanets could mark the next chapter in humanity's eternal quest for knowledge. Each new discovery ignites discussions and investigations and even challenges our fundamental understanding of life, intelligence, and the universe. For example, if we were to confirm that Proxima B, or another exoplanet, harbors life, it would force us to rethink our place in the universe. Could life elsewhere evolve similarly to our own, or would it represent a completely different kind of existence? Would it follow the same evolutionary paths, or would its biology and cognition defy everything we know about life on Earth? Even if we don't find direct evidence of intelligent life, the mere detection of artificial signals or lights from distant worlds would still carry profound implications. It would suggest the existence of advanced civilizations capable of altering their environments in detectable ways, affirming that intelligent life is not a rare phenomenon but perhaps a widespread result of specific conditions in the universe. At the same time, it's crucial to remain grounded and cautious. The potential for finding life is thrilling, but it also raises questions. What happens next? How would humanity respond to the confirmation of extraterrestrial life? Would we approach it with respect, curiosity, and scientific rigor? Or would the discovery spark panic, fear, or political conflicts? History has shown that humanity's responses to new discoveries, especially those that challenge deeply held beliefs, can be unpredictable. We must also consider the ethical implications of our curiosity. If we do find evidence of life, particularly intelligent life, what does that mean for our responsibility as stewards of our own planet? What moral considerations should guide our interactions with other forms of life, whether microbial or advanced? These are not questions with easy answers, but they will likely become central to the conversation as we venture further into the cosmos. The search for life beyond Earth, led by tools like the James Webb Space Telescope, represents a fascinating intersection of science, philosophy, and humanity's future. The next few years will likely bring more discoveries, more questions, and possibly even answers that challenge everything we thought we knew about the universe and our place within it. The story of our search for extraterrestrial life is, in a sense, just beginning. With each new development, we move closer to a moment that could alter the trajectory of humanity's history forever. As we continue unraveling the mysteries of space, the search for extraterrestrial life inspires a profound sense of wonder and urgency within the scientific community. Instruments like the James Webb Space Telescope offer unprecedented capabilities to explore distant worlds, bringing us closer to answering age-old questions that have persisted for centuries. One of the most exciting prospects is the possibility of finding life on exoplanets like Proxima B, a planet in the habitable zone of its star Proxima Centauri. This star system, located just over 4 light-years away, is part of the Alpha Centauri group, making it one of the most studied regions in our quest to discover alien life. While the search often focuses on microbial organisms, the detection of artificial lights or transmissions could suggest the presence of intelligent civilizations. This discovery would not only answer the long-standing question of whether we are alone but could also transform our understanding of the universe. As our technology advances, our tools become more capable of detecting signs of life or activity, even from worlds light-years away. These discoveries could pave the way for a new era in space exploration and, potentially, contact with alien civilizations. However, the search for extraterrestrial life also raises moral dilemmas. How would humanity respond if definitive evidence of alien intelligence were found? Would we approach them with respect and curiosity, or would we react with fear and uncertainty? The history of human exploration suggests that new discoveries often lead to unforeseen challenges, from cultural upheavals to geopolitical tensions. Thus, the implications of finding life elsewhere are scientific, philosophical, and ethical. The discovery of artificial lights or signs of alien life would force us to confront profound questions about our place in the universe. It would push the boundaries of our understanding, challenging our ideas of consciousness, intelligence, and life itself. Ultimately, our search for answers may not only bring us closer to understanding the universe but also reveal more